Howdy guys, and welcome to LE6. You've made it to the final LE, so we're wrapping up. Hope you've had fun so far. LE6 builds on PA3 by adding new messages from the server that you'll need to use signals to handle. We've added one message type to the message type enum, as well as one struct. So that's going to hold the new messages, and they will be going through the control channel. We'll get into that a little bit later. So something that I really want to stress is LE6 introduces error messages from the server. So we also test that you can handle that gracefully. In some of our test cases, we'll have the user give you incorrect input. So like the wrong patient number or the wrong file name. You'll need to be able to handle that without crashing or stalling. So that's also something new that we've introduced in this LE. Okay, so during the execution of data message and file messages, we will send new messages through the control channel using the sig message struct and the signal message type. So those messages come like we've seen before. They're just going to always be through the control channel. Once you get those messages, we'll stick them in a bounded buffer so that you can pull them up, and then call a signal so that your signal handler can do stuff with those messages. And I'll get into that a little bit more when I'm going over the starter code. So these are the functions that have been added to client. So the signal thread function, which will continuously read from the control channel, grabbing those messages, and then info sig handler and error sig handler. Those are going to be your signal handlers. So let's check how this looks like in the code. So if we go over to client.cpp, so these first three functions have been added, as well as these two bounded buffers that you'll use to store your messages, just the strings. You'll notice that everything else should be populated from your PA3. So copy your working PA3 code into the second part of this client.cpp file. If you don't have working PA3 code, please talk to me and we'll get it working. Okay, so the main guy that we'll talk about is the signal thread function. And this starts by initializing the error messages and the info messages bounded buffer. And then the next thing it should do is it should associate the signal handlers with the appropriate type. Sig user 1 will be the signal for info messages, and sig user 2 will be the signal for error messages. So when we get one of these two message types, we're going to push to the bounded buffer and then call the appropriate signal. So that'll be inside of our while loop. We're going to read from the control channel, make sure that we haven't been quit. So if the channel has been closed by the server or the other side, you're going to get a -1 value. So that's going to know that you get to break out of your loop. And so once we get a message, you'll check the signal type and then push it to the appropriate queue and send the appropriate signal. So for this last guy, you'll want to look at the raise function. And for these guys, you'll want to look at the signal function. And I would just check the man pages for that. That should be plenty helpful. Okay, so we've sent the appropriate signal to handle the message that we just got. Let's look at our signal handler. So all the signal handlers should do is have some sort of loop that reads until the queue is empty to make sure we get all of the messages in the queue. And then for every entry in the queue, we should see out info plus that message. Same thing for your error signal handler. We're going to loop until the bounded buffer is empty, and then print out error plus that message. Okay, so that's, and then obviously in your main, you'll want to launch your thread and then join your thread. And you can do, I would create the thread after you're done opening new channels. So the control channel, all it should be doing now is sending the new channel requests and then reading for those signal messages now. So we can like delimitate it where you say create worker channels and then start signal thread, and then start the rest of the threads. Start all other threads. That would be a good order to put those in. And then you can join them. It'll be like the last thread that you join so that you get all of the messages. That would be just fine. So I can put that in there. Join. There we go. Join signal thread list. That would be a good order to do that. But that should be the only changes that you need to make in main. The other changes would include making sure that you don't error or stall when you get an unexpected condition. So I'll go over this a little bit more, probably. So in your file thread function and your worker thread function, you'll want to be checking to make sure that we haven't encountered an unexpected condition. So specifically for your file thread function, on the C read, check if number of bytes returned, n bytes returned is less than 0. If so, returned, because we've hit an error. And then the next thing would be in your worker thread function, same thing. Check n bytes less than 0, and also check the message type. So if the message type is unknown, then return, because we've gotten an error. So both check n bytes for a channel that's been closed prematurely, and also check that the message type, if it's unknown, you'll want to return. And that's a sign that something weird has gone on. Cool. Let's talk about comment. I think is next up. Sure is. So if we go into the comment.h file, you'll see that in the message type enum, we've added the signal message. So that's going to be a new message type. And then I've also added this signal type enum, where this will tell you what kind of signal you'll want to be sending, either an error or an info. And these are all stored in our new class sigmessage, which has message type, just like before, where the enum for message type is right at the top. You still do that. It also has the signal type as the next guy, so that you can see if you need to send a sig user 1 or a sig user 2. And then it has a char star for the message. And this will always be max message is the biggest buffer size. I think that's all of the changes for comment.h. Bounded buffer, just like before, you're going to use your own bounded buffer. Nothing else has to change. Let me know if you don't have a working bounded buffer, and we'll get you sorted. Okay. Some other things to finish up. Since we're introducing error messages, please make sure your code can gracefully handle unexpected conditions. So just like I said, don't crash and don't stall if we have an error message, and we went over what that might look like. And since we're repurposing the control channel, so that new this new SIG message is going to be going through the control channel, please make sure that you only send new channel requests at the beginning to the server through control channel. Don't send anything else. So a lot of people in their file thread function will send the message to get the file size through the control channel. Don't do that here. Please make sure this has a different channel. Otherwise, you'll get unexpected output. And I think that finishes up what I wanted to talk about. Yeah, so again, look over PA3, since that's what this is based on, and then specifics on threads. In case you want that, you should be pretty familiar with starting a thread. And then signal, raise, join. Those are going to be the signal specific functions we are using. All right. And then if you want more details on what the server is doing, you can check out the server. So you can see in the process file request, this is what has been added on processing file. So it tells you how far along it is in processing the file and then sends that signal. Also, if for error messages, if you give it the wrong patient number or the wrong ECG number, you'll get this this error message. And we'll send back the unknown too, if something weird went off. And we do the same sort of thing for files, where if we get the wrong file name, we'll send you back an error message. A file cannot be opened. That's the file. And then we'll write you back this unknown message type, unknown message. So that's what you would expect. Good luck.